example 1 you try wants you to go ahead and determine whether the number is rational or irrational. First one, 2 over 3 repeating is 0.6 repeating. It's a nice repeating decimal, so this is a rational number. The square root of 100, even though it's a square root, it's a perfect square, comes out to be a nice whole number. 10, rational number. Square root of 7, it's not a perfect square, so whenever I go to take the square root of it, square root of 7 is equal to 2.64 575131109, which is the same as irrational. And lastly, we have the square root of 16 over 25. We learned that whatever we have underneath the square root, we should simplify first. So one way of doing this is to do just fine the square root of 16 over 25 on your calculator, you'll get an answer. Or that's the same as the square root of 0.64. Or you could think of that as the square root of 16 over the square root of 25, 4 over 5. So there's a bunch of different ways, but in the end you're going to get the decimal 0.8. Okay, so square root of 16 over 25 is equal to 0.8. This is a terminating decimal, so it is a rational number. Okie dokie. Let's go to the very last page of this lesson, which is asking us to do 2 more things. The first one is just to compare the real numbers, and then the second one is to order them from least to greatest. So here we have the square root of 2 and 9 over 5. What I'm going to do is I'm going to write both of them in the same form, which would be decimal. So the square root of 2 is a decimal 1.414, and it doesn't stop. It's a non-ending. This is an irrational number. However, I'm just comparing which is greater. So I only need to write out a few decimal places. This is 1.8. Obviously, the 1.8 is larger, so its square root of 2 is less than 9 over 5. Next, I have the square root of 7, which we just did. Square root of 7 is 2.645. And then I have 8 over 3. 8 divided by 3 is 2.6 repeating. This one is larger, so it's less than. Next I have 3 square roots of 2, so I put that in my calculator. 3 times the square root of 2 is 4.24264. So this is another non-repeating, non-ending decimal, so that's irrational. But I go to compare them, and I can substitute in 0, so I have the same number of decimal places. Now because these are negatives, it's less than. Even though this number is greater, oops, I forgot my name. Even though 4.242 blah 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 is greater than 4.2, being that they're negatives, it kind of flips things around. So the negative 4.2 is greater, it's a less than sign. Last one, 15 over 4. 15 divided by 4 is equal to 3.75. Then I have the square root of 15. Square root of 15 is 3.872 So another less than sign. This one number is bigger. Square root of 15 is larger than 15 over 4. So we did this whenever we studied rational numbers with fractions and decimals. Now we're just throwing in the square roots. Alright, last 2. We're going to go ahead and put everything in the same decimal form so that we can compare them nicely. And then from here, we're going to go ahead and put them back in. So this is first the decimal 3.16. 7 divided by 3 is the decimal 2.3 repeating. And then 2 square roots of 2. That's the decimal 2.828. Okay, now my smallest one is 2.3 repeating. So I can put them in order that way. My next smallest one is 2.828. 2.828. Next smallest one is 2.9. And then I have 3.16. Now I don't want to leave them in this order. 2.3 repeating was actually the third one, 7 over 3. 2.828 was actually 2 square roots of 2. 2.9 was just 2.9. And the last one, 3.16, is really square root of 10. This is your final answer. Okay, last one. Negative, and these ones have negatives, so we're going to think of them on the other flip version. But the square root of, or I'm sorry, negative 16 over 3 is going to give me negative 5.3 repeating. Negative square root of 22 is going to give me negative 4.690. Negative 3 square roots of 2 is going to give me 4.242. I feel like we just did that one. Maybe not. Negative 4.242. And then I have negative 4.6. Now because all of them are negative, everything, we're really looking for the largest number, because that means if you think about like your number line, oh, whoa, crazy. Let's make a nice straight one. A little better. This is 0, these negative 1, negative 2, negative 3, on and on and on. Even though the numbers themselves are getting bigger, they're actually getting smaller because they're going more to the left. So that negative kind of works backwards. So anyways, the largest one here would be the smallest of what you would think. So our least number is negative 5.3, or negative, 5.3 repeating, the smallest number. Next smallest number is going to be negative 4.690. Next smallest number is going to be negative 4.6. Next smallest number is negative 4.242. Last thing I want to do is put them back in the original form that they showed up in, which is negative 16 over 3, negative square root of 22, negative 4.6, and then negative 3 square roots of 2. And that's it. Alrighty. Nicely done, guys.